Hey guys, how are you doing? How's everything? And this is Dr. Sara. Today we're going to carry on the topic measurements, okay? And we're going to focus on density. And this is very important. Many questions are focusing on this topic. Okay, so in the classroom, I have already explained in a very simple way what is the meaning of the term density. Density, in a very simple way, is the crowdedness of something. So I have mentioned the example of people in a street or students in a classroom. Okay, when do we say that this classroom is crowded? Actually, when there are so many students in the classroom. And the same thing, when do we say that this street is crowded? When it has lots of cars or lots of people in a certain street or a small street. Okay, so in science, we define density as the mass per unit volume. So what's the relationship between mass and volume and people in a street, for example? So I have already related this as the people are the masses and the street is the volume. Okay, similarly, the students are the masses and the classroom is the volume, right? Okay, so here we go. Now the density is the mass in a certain volume or the mass per unit volume. This is the definition. And as you can see in the screen, that solids are more dense than liquid. Why? Because solids contain more particles in a certain volume than the particles in the same volume of the liquids. Similarly, liquid is more dense than gas. Why? Because the number of particles in a certain volume of the liquid are more than the number of particles in the same volume in the gases, right? And afterwards, we had mentioned this comparison that which square is more dense. So definitely the one on the right hand side. Why? Because it contains more particles in a certain volume, which is the same volume as the square on the left hand side. Right? Now, this part is very important, right? And you must memorize how to calculate the density, okay, from given mass and volume, or to get the volume if you have the density and the mass given, or to calculate the mass if you have the density and the volume given. In all of the scenarios, you're going to have two given parameters and you're going to calculate the third one, right? So density is equal to the mass per unit volume, and the unit of density is depending on the unit of the mass and the volume given in the problem. So for example, if the mass is given in grams, right, and the volume is given in centimeter cube, so the unit is going to be grams per centimeter cube, right? Or if the mass is given in kilograms and the volume is given in meter cube, so the density in this case is going to be in kilograms per meter cube. So it depends on the units given in the example. Here we go. Now I just need you to have your calculators, have your paper and pen, and do these calculations yourself, okay? You must use your pen and the calculator in order to get the idea. Otherwise, if you're going just to watch the problems, you're not going to be familiar with calculations. Okay, so for example, in this, if the mass of an object is 35 grams and it takes up 7 centimeter cube of space, calculate the density. And we agreed that taking up a space means this is the volume. So you have the mass and the volume given. That's a very simple example. You just need to follow some steps to be organized enough and to mention which is given, the mass and the volume, and what is unknown, which is the density. And you can just substitute in the rule, which is the formula, 35 divided by 7, and then get your calculation. Please don't forget to mention the units. And in this example, why did we choose grams per centimeter cube? Because already the mass given is in grams and the volume given is in centimeter cube. Here we go. Now you have 4 more examples and you follow the same steps. Okay, please try to do them yourself. Okay, and you have already the answers mentioned. Right now, example number 2, a cuboid has dimensions of 9 centimeters, 3 centimeters, and 12, right? And it has a mass of 194.4 grams. Now, since you have the dimensions of the cuboid, so you can get the volume of the cuboid from these dimensions. You can simply multiply the three values, 9 multiply 3 multiply 12, right? And then you get the volume. Afterwards, you're going through a second step, which is calculating the density by simply dividing the mass by the volume, right? Okay, so the base by the height by the depth, and you just multiply the three values and you get them in centimeter cube. And I have already mentioned why cube, because we are multiplying three dimensions with each other, so it's in centimeter cube power to the power 3. All right, here we go, completing this example. So we get the volume of the cuboid, and you have already the mass. You can simply compensate and you get the density by 0.6 grams per centimeter cube, right? The unit counts for one more, guys. Please make sure that you have written your units. Right, now example number 2, this example is somehow tricky, or it needs more steps, because the dimensions of the cuboid are given in meters and in centimeters, while the density is given in kilograms per meter cube. So you have two options, either to change the dimensions of the cuboid all to centimeter, but in this case, you will need to change as well from meter cube to centimeter cube in the density. So this is a long scenario. We have chosen the other option, which is just converting the centimeters into the meters. Why? Because already the density is given in meter, so it's easier to make only one step of conversion, right? So we started by simply converting centimeters into meters, and then we multiply the three dimensions together, right? And we get 2.52 meter cube, which is the volume of the cuboid. Now already the density is given, so we need to calculate the mass, right? Mass equals density multiplied the volume. You just substitute in the rule and you get the mass. And why the mass here is in kilograms? Simply because the density was already given in kilograms, right? Okay. Now there are some factors that are affecting the density of the substance, and because the density is equal to the mass per unit volume, so whatever the change which is happening in the mass is going to affect the density, or if you change the volume also it's going to affect the density. And as we agreed, because density and mass are both nominators, so they go the same way. For example, if the mass increases, the density will increase. Okay, the higher the mass, the higher the density. And in simpler words, if too many people, too many masses are in the same place, this is going to increase the crowdness, therefore increasing the density. Now, for the volume, a second scenario is going to happen, or it works in proportional, means that if the volume increases, means that you're going to make the streets bigger, for example, this will decrease the density. So the density and the volume are going in proportional or indirectly proportional to each other. Means that if the volume increases, the density will decrease. And if the volume increases, the density will decrease. So because the density and the density is a numerator and the volume is a denominator, so they do not go the same way. They are in proportional to each other or indirectly proportional, right? Okay, now how to change the mass if you have a certain volume? Okay, now the M&Ms are the particles, means that the M&Ms are the masses, and this square is the volume in which the masses are in. Now, if we need to change the mass and keep the same volume, so we need to think to have the same square, right? Because this is the same volume. And we just need to change the number of M&Ms inside the box. So it could be like less or more. Both are correct, okay, in this case we have chosen to add more M&Ms. Okay, now changing the volume and keeping the same mass. If you have this square, again, the square is the volume and the M&M's particles are the masses. So if you need to change the volume, we need to have a different size of the square, maybe smaller or maybe bigger. Both are correct, right? Okay, now I have already demonstrated for you the floating of oil layer over water, right? And we agreed that the less the density, the more the less the density of the substance, it will float. Okay, so we arranged these liquids from the heaviest or from the most dense till the least dense on the top. Please bear in mind that if you have a tube of 5 liquids of different densities, the one which is having the most density or the most density is going to be in the bottom, followed by the one which is less, again the less, then the least one or the least density one on the top. You just need to make a simple arrangement, right? Descending order from the big to the smallest, and to put the biggest density liquid in the bottom and the smallest density liquid in the top. Here we go. This example goes the same way. We just need to arrange the densities of different liquids, right? Again, the most density liquid is in the bottom and the least density liquid is in the top, right? And we have compared why the sponge is floating and the piece of the brick is going to sink, since they have the same volume, right? But the thing is, they have different masses, right? And we agreed that the more the mass, the more the density. Since the brick has more mass than the sponge, right? So it has more density, so it's going to sink rather than the sponge is going to float. Now it comes to the relative density, and we explained that relativity means that you're comparing the substance with another standard thing. And definitely we are choosing water as a standard thing. Why? Because the density of water is 1. If you have some water at home, if you just calculated the mass and the volume of this water, you're going to find that its density is 1, right? So the relative density is just a value that expresses the relationship between the density of a substance compared to water. Okay? One more thing, if the substance density is less than 1, it's going to float. And if it's bigger than 1, it's going to sink. However, if the substance or the object has the same density as the liquid in which it's put in, so this object is going to be suspended in the liquids. Please consider that this liquid is water as long as we're mentioning that this is the relative density, and relative density is about water. Okay, I ended up the session by asking you the question, why it's easier to float in the sea than in rivers or swimming pools? Okay, again, since the salty water in the sea contains salt, and salt adds more atoms and particles to the water, so this means that the particles in the sea are more in a certain volume than the particles in the river. Again, if we take, for example, 100 milliliters of salty water and 100 milliliters of fresh water, you're going to find that particles in seawater are more in number than in the fresh water, despite that you have the same volume, which is 100 milliliters, right? Now, since it has more mass, more atoms mean more mass. So more masses means it's denser, okay? So because it's denser, so it's easier to float in a more dense water than in a fresh water. Okay, so that's all for today, and that's all for this chapter. Thank you for being with me today, and please don't forget to study well, right? And please study page 10 also. It includes the weight and the mass comparison. Okay, wish you the best of luck ever, and thank you and goodbye.